साइंस एंड टेक्नोलॉजी का कुछ टॉपिक यहाँ पे रीड करूँगा, तो इस लाइव सेशन में देखते रहे। तो पहला जो चैप्टर है, जनरल फिजिक्स एंड द एवरीडे केमिस्ट्री। जनरल फिजिक्स, मैकेनिक्स, scalar and velocity quantities. Scalar has only the magnitude size. Example: distance 5 meter, speed 60 km per hour, mass 10 gram. Vector has both the magnitude and the direction. Vector follow the triangle law of the addition. The vector simply means the displacements from the point A to the point B. Now the consider the situation that the graph moves from A to B and then from B to C. The net displacements mapped by the curves from the point A to the point C is the given by the vector and the expression A C bar is equal to A B bar plus B C bar. This is the known as the triangle law of the vector addition. Example: displacement 5 meter is velocity 6 km per hour, not force system, not downward. Some key term: velocity. Velocity is the vector quantity that represent the rate of the sense of the object positions with respect to times in the specific direction. It tells both how the fast and the object is the moving, the speed, and which the direction. P is equal to delta S by delta T, where P is equal to velocity, delta S is equal to displacement and in position. Delta is equal to time interval. Velocity differs from the speed because it includes the direction, making it the vector quantity. Acceleration, it is the defined is the rate of the sense of the velocity with respect to the a is equal to del v by del t, where a is equal to acceleration, del v is equal to sense in the velocity, del t is equal to time interval. Momentum. Momentum is a momentum is a vector quantity that represents the products of the object mass, and it is the velocity. It indicates how much the motion and the object forces and is the given by the equation P is equal to mv, where P is equal to momentum, V is equal to velocity, and m is equal to mass. Law of conservation of momentum. According to the law of conservation of momentum, the total momentum of the isolated system remain the constant if no external forces act on it. Application: suppose the person is the stroke in the middle of the frozen black, which the offer almost no frictions with his shoes. He cannot simply walk and comes out as the friction is the required for the walking. How can he come out? If he has got the system back and no other tools. Solution: we can apply the conservation of momentum here. If they throw the bags in one direction, the bags will get the velocity and thus the momentum in that direction. The man will attain velocity and momentum in the opposite direction, so that net momentum of the man plus bag remains zero as no external forces in the apply on the man's plus back system. Friction is zero. Forces and the Newton's law of motion. Force. The force is the plus of plus or the per extent on the object that the causes it is the sense, it is the velocity, accelerate or shape. It is the vector quantity and is the measured in newtons. Newton's first law, law of inertia. If the body remains in the state of the rest of the uniform motion in a straight line unless acted upon by and the external forces, example a book on the table stay still the until you don't push it. Newton's second law, law of acceleration. The acceleration of and the object is directly proportional to the net force acting on it and the inversely proportional to its mass. This means to give the equal acceleration to two objects, one need to apply the greater forces on the heavier object. Equation F is equal to ma, where m is mass and a is the acceleration. This the equation can be expressed in terms of the momentum also. F is equal to del p slash del t, meaning forces is the rate of the sense of momentum. Example: a car accelerates faster when the passes with the greater forces. Newton third law, action reaction. For every action there is an equal and opposite reaction. Example: a rocket moves the upward by the expelling gases downward. The gases being the forces that downward the pass the rocket upward as explained by the third law. Friction. The friction is a force that opposes the relative motions between two surfaces in contact. It arises due to the interactions at the microscopic levels of the surface involved. Greater the surface areas in the contact, greater will be the friction. Types of friction: static friction. The forces that the must be the overcome to the state moving an object at rest. Kinetic friction but sliding friction. The forces that are opposite the motions of two surface slidings against each other. Rolling friction. The resistance encountered when an object rolls over the surface. Here the surface area of the contract is reduced and thus the moment become easy. Example: ball bearing bearing ball bearing. The balls roll between the inner and the outer rings. Contract surface is limited to the single point at the board surface, thus the greatly reducing the friction and making the motion smooth. Circle motions and the centrifugal force. Circle motion is the movement of and the object along either circle, but it can be the uniform constant speed or the non-uniform changing speed. The circular motion is always the accelerate as the direction of the speed change at every instant. Imagine the rotating the stone tied to the string in the horizontal cycle. You will have to apply the forces on the string toward the center of the circle and every instant so that it remains in the circle. P show directions of the velocity, A show the centripetal acceleration and also the direction of the force applied by the string on the stone. Omega is the angular moment, velocities and is the given by the angle covered for unit times in the circle motion. Centrifugal acceleration direction toward the center of the circle. Calculation as a visual velocity r is equal to radius. Acceleration is equal to v squared by r. Centrifugal force is equal to mass into centripetal acceleration. The net force that required to keep and the object in the circular motion. Here is equal to Fc is equal to mv squared by r. Centrifugal force. Definition: the centrifugal force is the efficient outward force felt by an object moving in a circle possessed by the interior. It is the direct away from the center of the circle. Application: skimming of milk. The milk process one and the container is the spoon. The creams less dense moves the upward due to the centrifugal force, allowing the separations from the milk. Vehicles on the carpet road. The centrifugal force that gave cars on the road insufficient frictions can lead to the skidding. Satellites that remain in the orbit due to the centrifugal force from the gravity. Shapes of Earth. Of length, the shape shape is due to the greater centrifugal force near the equator. Centrifuges. The separate the substances by the spinning them rapidly, utilizing centrifugal force. Tides. The combine the effect of the gravitational force of sun, moons, and the centrifugal force due to rotation of the earth on the axis. Pressure. Definition: pressure is the force that exerted per unit area. P is equal to Fa, where P is the pressure, F is equal to force, and A is the area. It is the measure is Pascal. Atmosphere pressure extra. 1 Pascal is equal to 1 Newton by meter square. 1 atmosphere is equal to 1 atmospheric pressure is equal to 1.013 is equal to 10 to the 5 Pascal. Flow of fluid pressure difference. The fluid flow from the areas of higher pressures to the areas of lower pressure is the principles that govern many systems, such as the water supply, is the pipes, and the blood circulation in the body. Pressure and altitude pressure variation. Atmospheric pressure that decreases with the altitude because the densities of the air decrease as the altitude increase. This phenomena explain why the higher altitude have lower oxygen availability, impacting the human physiology and the performance. The cookings of the rice at the higher altitude. Cooking silence. At the higher altitude, the atmospheric pressure is the lower, resulting in the lower boiling the point for the water below 10 degrees Celsius. This means the rice and other food take the longer to cook, as water does not rise as the high the temperature. Boiling point of water and increase the pressure. The boiling point of water increase with an increase in pressure. At the higher pressure water, the molecules require more energy, higher temperature to the escape into the heavier phase. The means water boils at the temperature higher than 10 degrees Celsius. Cooking of the rice in the pressure cookers. The pressure cooker rice in the boiling point of water due to the increased pressure inside the cooker. This allows the rice and other food to the cook faster, as the temperature inside the cooker can exceed 10 degrees 100 degrees Celsius. Application of the pressure in hydraulic lift. Hydraulic lift. This the Dryses is the principles of the full the pressures to the lift heavy the object by the applying the small forces on the piston. The large forces is the generated through the fault the allowing from the lifting the capabilities in the hydraulic system, such as the car lift and the elevator. Practical applications of the pressure straw use. When you the sash on the straw, you create a low pressure area inside the straw. The higher atmospheric pressure the outside the pushes the liquid up into the straw allow you to the drink. Land and sea bridges. Bridges formation. Land bridge. At the night, land cool faster than the water, creating the higher pressure over land and the lower pressure over the sea. The wind blows from the land to the sea. Sea breeze. During the day, the land heats up the faster than the sea, causing lower the pressures over land and the higher pressures over the sea. The wind blows from the sea to the land. Cloud formation and rainfall. Cloud formation. Cloud form in the areas of the low pressure when warm the moist air rises and the cools, reducing it is the capacities to the hold the moisture as the air cools water vapor condenses into tiny droplets, the forming cloud. The rainfall when the cloud the droplet coalesce, coalesce and the grow heavy the enough they fall as the precipitations rain. This the process is the influenced by atmospheric pressure variation. Desert formation. Desert conditions. Desert Desert often form in the areas of the high pressure where dry the air distant and the inhabiting cloud formation and the precipitations. This leads to the arid conditions and the limited rainfall. Cloud dynamics. Laminar flow. In the laminar flow, the fluid the moves in the parallel layer without the maximum velocity at any point in the fluid remains the constant over time, and the flow lines are the smooth and the orderly. These types of the flow the occur when the Rayon's number is the dimensions number that indicates flow types in flow. Example: blood flowing through the narrow capillaries. Flow the laminar flow where and is the lower of the blood moves the smoothly past the others. Laminar flow. Turbulent flow. Turbulent flow is the chaotic with the irregular velocity and the difference point in the flow. The eddies and vortices form and the flow becomes the high mix. Turbulent flow the occurs when the Reynolds number is high. Reynolds number is high, indicating that the internal forces that dominate over the various forces. Example: water rushing through the large pipes or the river exhibited turbulence with the swirlings, the current and the upper unpredictable flows by turbulent flow. Diffusion. Diffusion is the random movement of the particles like atoms of the molecules due to thermal energies over time. The particle the speed out from the regions of the high concentration to the low concentration until the equilibrium is the recess. It is the governed by the Fick's law, who is the state that the rate of the diffusion is the proportional to the concentration gradient. Example: the diffusion of the oxygen into red blood cell across the alveolar membrane in the lung. When the concentration of the oxygen is the higher in the alveoli than in the blood. Osmosis. Osmosis is the special cases of the diffusion involving the movement of the water across the semipermeable the membrane. Water moves from the regions of the low cellular concentration to one of the high cellular concentration to balance the concentration on both sides of the membrane. It is the driving by the osmotic pressure. Example: balance route the absorbed water from the soil through the osmosis as the concentration of water is the higher in the soil than in the root cell. Dialysis. Dialysis involves the selective movement of the solid the particles through the semipermeable membrane based on the size or the concentration. It uses the diffusion to remove the unwanted the particles such as the toxins or the waste the products from the solution, allowing only the small molecules to the pass through the membrane. In kidney dialysis, the machine used to the semi-permeable membrane to remove the waste product from the blood of the patients with kidney failure. Surface tension. The surface tension the areas the because the molecules at the surface of the liquid experience the net inward force due to the Gaussian attractive forces between the similar molecules. This create the skin on the liquid surface the mimicking it is the surface area. Example: water droplets on either lid the plate up due to the surface tension and the small the insect like the water striders can walk on the water without the sinking. Water droplet like the spherical shapes because the surface tension forces the water molecules inward, reducing the surface areas as the mass as possible. The sphere has the smallest surface areas for either given the volume, so it is the most efficient shape. Capillarity, capillary action, physical explanation. Capillarity occurs when the liquid spontaneously rises or falls in a narrow tube due to the adhesive forces between the liquid and the tube's walls and the concept forces within the liquid itself. Shape of meniscus. Concave of the convex of or the flat depends upon the whether the concept forest among the molecules of the liquid dominate over the adhesive force between the capillary tubes and the molecules of the liquid. Cohesive greater than adhesive is equal to convex of the mercury liquid level falls as the shown. Adhesive greater than cohesive is equal to concave of the water liquid level rises in the capillary tubes as shown. Example: capillary action help water travel up the xylem in plants, allowing water to reach the top levels. Heat and thermodynamics. Temperature and heat. Temperature definition. Temperature the measure at the average the kinetic energy of the particles in the substance determines how hot or either cold the substance is. Unit measurement in the Celsius, Fahrenheit or Kelvin. Kelvin is the SI unit directly related to the absolute temperature. Heat based temperature. Heat the energy transfer due to the transfer difference measurement in joule. Temperature is the measure of the average motion of the particles in the substance. Definition: heat the depends on the mass and the temperature difference, whereas the temperature is another intensive properties does not depend on the amount of substance. Heat transfer and the conductivity. Good and bad conductors of heat. Good conductors. Materials like the metals that quickly transfer heat due to the free electrons. Bad conductors the insulators, the materials like the wood or the rubber, which the restrict heat flow, the making them useful for the insulation. Modes of the heat the transfer conduction. Transfer of the heat through the direct contact, that is by example is equal to metal rod in the flame. Convection heat transfer through the fluid motion, example boiling water. Radiation heat transfer within the medium through the electromagnetic wave, example heat from the sun. Specific heat capacity and it is the application. Specific heat capacity. Definition: the amount of the heat the need to the rises to the temperature of 1 kg of the substance by the 1 degree Celsius. High specific heat of water. Water require more energy to the sense it is the temperature which the establishes Earth's climate. Application: ocean and climate. Ocean is to last the amount of the heat due to water's high specific heat during the winters. Ocean releases this the heat slowly keeping coastal regions warmer. Relation between the surface areas and the rate of cooling. Newton's law of cooling. The rate of the heat loss is the proportional to the surface area and the temperature difference between the object and is the surroundings. Larger surface areas result in the faster cooling. The larger temperature difference between the object and the surrounding lead to the large rate of the cooling. Example: at the 60 degree Celsius iron rod cools the faster in the room at the 5 degrees Celsius than in the room at the 15 degrees Celsius. Water phases and the special properties. Phase of water. Water exists in three phases: solid, ice, liquid, and gas vapor. Phases as they involve the latent heat, the energy absorbed or the released without the sensing temperature. Latent heat definition: energy liquid. um, Latent heat definition: energy required for other substance to the sense it is the phase. Example: from the ice to the water without the temperature sense. Sufficiency: latent heat the experienced by ice that absorb the large amount of the energy when the meltings, the establishing temperature, water is the mixing, human density and the process like density anomaly. Water is the density at the 4 degrees Celsius. This causes like to the freeze or on the surface first, while the denser warmer water the strip along the aquatic life or to the surface. Black body radiation. Black body, it is the perfect absorber and the emitter of all the wavelength of radiation. The black body emits the radiation based on it is the temperature. This the principle is the fundamental to the understanding the heat emissions of star and the planet. Greenhouse effect mechanism definition. The greenhouse effect is the trapping of the sun's heat by the earth atmospheric through the gases like carbon dioxide, water vapor, and the methane. Important, it keeps the earth warm enough for life or by the preventing excessive heat from the escaping into space. Cloudy night and the greenhouse effect. Warmer night. The cloud act as a thermal blanket, trapping heat during the night, which the prevent rapid cooling. This is an extension of the greenhouse effect. Cryogenic and it is the application. Cryogenics is the study of the material at the very low temperature such as the below minus 150 degrees Celsius, developing the unique the properties like the superconductivity. Key application. Cryogenic cryogenic refrigeration used to the freezing biological simple example liquid nitrogen. Superconductivity materials. The critical in MRI mechanics and the particle accelerators. Accelerator example large hadron collider. Space exploration. Utilize the cryogenic fuels, liquid hydrogen, oxygen for the rocket propulsion. Medical application. Cryosurgery employs the liquid nitrogen to the remove tumors. Cryopreservation, the cells and the tissue stored at the ultra low temperature for the fertility treatment. Scientific research, the study material is the condensance matters, the physics and the quantum mechanism. Industrial application, natural gas, the liquid fractions for the efficiency transport. Optical optics and sound. Optics, light is the radiant energy that travels in waves. The scientists have long the debate it is the nature and now the understand that it behaves both like work and the particles in the become light moves at a constant speed of about 299,792 kilometers 186,281 miles per second with the measurable wavelength. Reflection definition. The bouncing back of the light when it hits the smooth surface governed by the law of reflection. Law of reflection. The angles of the incident equals the angle of reflection. The incident ray, reflected ray, and the normal to the surface lie in the same plane. Particle application of the reflection mirrors used for the grooming, safety, and the optical divers. Solar cookers, the employ parabolic mirrors to the concentrate sunlight for the efficient cooking. Press cooker and the optical instrument utilize the reflection the particles principles reflection principles for the viewing from the concentrate position. Refraction definition: the bending of the light as it is the passes from one the mediums to the another. It is the described by the Snell law. Core physics principle: the sense is the speed of the light in different media result in the reflection. The refractive index and of the medium is the defined as the ratio of the speed of light in either vacuum to the speed of light in that medium, and is equal to c by v. Conference denser medium, light slow down and the bends toward the normal when the entering the denser medium. Example: air to glass. This causes the parallel ray to the convergence through to the convex lens. Application is in the camera, microscope, and corrective lens for the hyperopia, farsightedness, divergence, less dense medium. Light is split up and bent away from the normal when the exiting at the denser medium. This causes to the diverge through the concave lens. Application used in the glasses for the myopia, nearsightedness, and it in the expanding laser beam. Particle applications and the observation lenses in glasses and the camera. The correct visions and the focus image. Employing the advance in the optical and the material science. Contact lens made from the hydrophilic materials that maintain moisture, improving the comfort and clarity. Red sky and the drone and ducks. The scattering of the shorter wavelength of the light during sunrise and the sunset lead to the vibrant color in the sky. Demonstrating the principles of the light reflection and the scattering. Total internal reflection (TIR) definitions: the occurs when the light traveling from the denser to the less dense the medium is the completely reflection at the boundary above of the critical angle. The particle application optical fiber use TIR to the transmit data over long distance with the minimum loss, revolutioning telecommunications and the internet technologies. Diamond sparkle. The brilliance of the diamonds in the enhanced by TIR causes them to reflect light in the multiple direction. Mirrors. The mirrors is naturally the occurring optical the phenomena in which the light rays win by the reflection to the bodies in the displaced image of the distance object on the sky. They create and the illusions of water in desert when they looked from far away. Dispersion. Definition: the separations of white light into it is the component colors of when the passing through the prisms due to the varying the reflective indicates. Particle application, spectros- spectroscopy, analysis at the spectra from the celestial bodies, the crucial in astrophysics for the understanding the universe, the composition, rainbow formation, the natural display, the resulting from the light dispersions, the reactions, and the reflection in the raindrops, mirrors. Definition: the reflective surface that from the image that classified into plane, the concave and convex mirror. Particle application, convex mirror used to the telescopes to the gather and the focus light for the enhance the atmospheric observation. Convex mirrors, the period with the uh, field of the view in the safety application, improving the traffic safety and the surveillance license. Definition: transparent object that the refract light to the convex of the river, hence the concave ray. The particle application, microscopes and the telescope employ the combinations of the lens to the magnify small or the distance object, advancing biological and the astronomical research. Bionic eyes that utilize advanced optics to the restore visions, the integrating biomedical engineering and the electronic sensor. Monash University in the Australia has the united the generous bionic vision system in the pioneering bionic eye designed to the restore visions by the bypassing damaged optic the nerves and the sending signal directly to the brain. The following the promising the animal studies, the human clinical trials are the set to the commonest in Melbourne. Prism. Definition: geometric opticals that diverge that the refract light, often the lending to dispersion. Practical application: prism, binoculars, prism binoculars use the prisms to the shorten optical path while the maintaining clarity essential in the outdoor and the military application. Brownian motion. Definition: the random motions of the microscopic particles that suspend in the fluid, the resulting from the collision with the molecules in the medium. The practical application: nanotechnology. Understanding Boeing the motion is crucial in developing nanomaterials and the drugs the delivery system, the optimizing their movement and the interaction with cell. Doppler effect. Definition: the sense in frequency on or the wavelength of the wave in relation to the observer moving the relative to the sources of the wave. The particle application, the observation. Astronomy is to the measure the velocity of the star and the galaxy, determining their the movement and the helping to the reveals the expansion of the universe. The redshift indicate object moving the away, while the velocity indicate object moving the closer. Medical imaging employed in the droplet, the altered sound through the access the blood flow, the providing the critical data for the cardi- cardiovascular health diagnostic sound of the passing train. The frequency of the sound wave the increase as the train approaches the higher speeds and that decreases as it moves away lower speeds. Human eye and vision structure light enter through the cornea reflect through the lens and form an image on the retina, which is the convert into the signal for the brain. The particle application optical technologies lens designs for the visions the corrections is the informed by the understanding optical physics enhancing the safety and the quality of life. Bionic eyes technology merges optics and the electronic using the sensor to the convert light into the electrical signal emanating to the restore vision in the individual with the retinal digest. Sound definition. The sound is the form of the mechanical energy that travel in the wave through the different mediums such as the air, water, and the solid. Compression to light. NASA sound is the longitudinal wave while the light is the uh, transfer wave. Types of the wave: longitudinal wave and the transfer wave. Medium recruitment. The sound require the medium to the travel, whereas the light can the travel through the vacuum. Speed of the sound in the variation medium air approximately 343 meters per second. Water above the 1 1480 meters per second. Solid, that is the state, approximately 5960 meters per second. Reason for the difference in speed. The speed of the sound varies based on the medium's density and the elasticity sound travel. Sound travel faster in the solid than in the liquid and the faster in the liquid than in the gases because the particles in the solid are the closer together and can transmit vibrations more than quickly. Unit of sound. The loudness of the sound in the measure in the decibels dB. The frequency of the sound is the measure in the hertz. Range of the audible sound. Humans can typically hear the sound in the range of 20 hertz to 20,000 hertz. 20 k is that. Hypersonic and the mass definition. Hypersonic refer to the speed greater than Mach 5 or 5 times the speed of sound. Mach number at the dimension at the dimensional unit the representing the ratio of the speed of and the object to the speed of the sound in the surrounding medium. Sonic boom. At the sonic boom that occurs when the object travels the faster than the speed of sound, creating the shock waves that produce the loud sound that's similar to and the expression or, organ pipes and the principle. The organs pipes produce the sound through the vibration of the air columns within the hollow tube. The sound is generated by the movement of air which create the standing wave the landing to the productions of the musical note. Example, flute, the saxophone Harmonia extra. Doppler effect. The Doppler effect is the sense in the frequency or pitch of the sound as the source the move the relatives to and the observed. For the example, when and the ambulance approaches the scissor sound higher in the pitch and as it is moves the away and the pitch lower. Application of the sound in the modern science and technology. Medical imaging. Ultrasound is the high frequency sound wave to the create image of the internal organ. Navigation. The sonar sound. The sound navigation and the beginning employs the sound populations to the navigate and detect object underwater. Acoustic levitation. The using sound waves to the lift is mold the particles or the droplet in the air without the physical contact. Audio technology. The speaker and the microphones convert the electrical signal into sound and the vice versa. Essential for the communications diverse. Electricity and the magnetism. Basic concept. Electric charge. Definition. The property of the matter then the causes it to the experience the force in an electromagnetic field. There are two types of the sense, the positive and negative. Application is in the capacitor to hold the store energy, crucial for the electronic curiosity and the device. The electronic current definition. The flow of the electrical charge through the conductor measured in the amperes. It can be the direction DC or the alternative AC. Application powers the household, the application electronic device and the industrial machinery. DC is the use to the batteries while the AC is the use for the home electricity supply. Voltage, electric potential. Definition. The difference in the electric potential between 2 points in the circuit measured in the volt. Application. Essential for the operations of the electrical system. Higher voltage allow for the efficient power of the transmissions over the long distance, reducing energy loss. Resistance. Definition. The opposition to the flow of the electrical current measured in ohm. It varies with the material's length and the cross section. Application used in the heating the element like the cloister, light bulb and the electronic device where the controller resistance is needed. Ohm's law. Definition. Instead that the current I is the directly proportional to the voltage and the inversely proportional to the resistance. Equation V is equal to I into R. Application. The fundamental in the designing in the circuit, the ensuring the component operator with in the sub limit. The series and the parallel the circuit. The definition. The series circuit. The component connected into the same current flow through all. The parallel the circuit. The component the connected across the common the point same the voltage across all. Application. The series circuit are used in the string light while the parallel the circuit are used in the home wiring to the ensure appliances and can the operate the independently. Magnetic field definition either reasons the around either magnetic materials or the moving the electrical charges the where the magnetic forces are the experience experiences the measure in Tesla natural phenomena. The earth the magnetic fields the protect the planet from the solar radiation and help the animals the navigate during the migration. Electromagnetism definition: the interactions between the electrical charge and the magnetic field, the sensing electrical field, the generate magnetic field, and vice versa. Application used in the electrical motors, generators, and the transformer. Electromagnets are the essential in the various the application, the including the MATLAB trans and the MRI machine. Faraday's laws of electromagnetic interactions definition: a surge in the magnetic flux through the circuit indices the electromotive force EMF application utilized in electric generator while the mechanical energy is the converted into electrical energy also crucial in the wireless sensing technology application in the modern science and technology. Electrical motors convert electrical energy into the mechanical energy found in the electrical vehicles and the household application. Transformer adjusts the voltage travels for the efficient power transmission, minimizing energy loss over the long distance. Magnetic resources imaging MRI utilize the strong the magnetic fields to the create details the image of the tissue reproducing medical diagnostics. Wireless communication. Electromagnetic waves are the fundamental in the technologies like the Wi-Fi, Bluetooth, and mobile communication. Natural phenomena. Auroras caused by the stars caused by the charges the particles from the sun interacting with earth magnetic field creating the stunning display of the light in the polar region. Lighting the natural discharges of the electricity that occurs due to the difference in electrical charge between the cloud and the ground. Chemistry in everyday life. Chemistry in everyday life. Chemistry touches every facet of life from the medicines and food to the cleaning, the agent and the cosmetic. This the chapter delves into the roles of the chemistry in our daily lives. The focusing on the medicines, food, the materials, cleansings agent and the important chemical in the news for the various reasons. Medicines and drugs. The medicines are the chemical compound that interact with the biological system to the threat element incorrect uses and the lead to the toxic effect. The fields of the chemotherapy refers to the use by the chemicals in uh, therapeutics treatment. This section also the includes the recent drugs, the discoveries, and the essential medical chemicals. Classification of the drugs. Classification based on pharmacological effect. Pharmacological effect. Example include the paracetamol, paracetamol by antipyretic, uh, ibuprofen by Inglysic, and classification of the drugs. Classification based on pharma, pharma, pharmacological effect. Example include the uh, paracetamol, paracetamol, antipyretic, ibuprofen, analgesic, and the cornoic antimalarials. Newer the drugs like the remdesivir and the Paxlovid for COVID-19 are also the xenonic attention. Drugs action. The drugs like antiviral uh, medications such as the favipiravir act on the viral replications, while the antihistamines, example loratadine and cetirizine, inhibited the actions of the histamine in the allergy reaction. Chemical structure drugs such as sulfonamides. Example: the sulfodiazine are the classified based on the structure, the similarities making it the assay to the predict their activity. Molecular target: in the addition to the proteins and the nucleic acid, newer drugs the development target the enzyme. Example: protease inhibitors used in HIV treatment, and the receptors like the ACE2 in COVID-19. Drugs target interaction: enzyme as the drug target. Enzymes the inhibitors such as the nebrifine SIV, and the newer drugs like nirmatrelvir, the potash inhibitors for COVID-19 show how the drugs interact with the active site. Receptor as the drug targets: opioid receptor the targeted by the drugs like the naloxone uses in the opioid the overdose treatment are the crucial in the managing plan and addiction. A recent development in the medicine: monoclonal antibodies. Monoclonal antibodies, drugs like the toxilizumab and the ringeners, the antibodies, the cocktails have been the highlights for the student COVID-19. Thank you so much. So